Then I am going to discuss about solvable for y. Our next concept is solvable for y. What is this solvable for y and when we have to apply this? What is our given differential equation? What is the general form of a first order but not first degree ordinary differential equation? If the given DE differential equation f of x comma y comma p. What is it? X comma y comma p. P is nothing but the equation may be in terms of x, y, and p. P is nothing but d by x. D by x whole power 2 or whole power 3 like that. Okay. So if the given differential equation, this one cannot be written as or cannot be expressed as product of linear factors in terms of p. Product of linear factors in terms of p. That means like our previous procedure. If we are unable to convert it into solvable for p, then we have to convert it into either it may be reducible to solvable for y or solvable for x. Then either it may be converted to solvable for y or solvable for x. Or solvable for x. This is a concept. When we have to go for solvable for y and when we have to go for solvable for x. That is an important point here. Okay. So for that, first point, if the given the degree of y is 1 in the given differential equation in given DE, then it is we have to apply solvable for p method. Solvable for y. Okay, this is the thing. If this is the thing, then what is the procedure? Then write equation 1 as y is in functions of x comma p variables. Then we're going to get y can be written in terms of x and p variables. Okay, then differentiate this one, y is in functions of x comma p, or directly the given differential equation number 1, anything we can write equation 1 with respect to x on both sides. And when we differentiate x with respect to x variable, what we'll get? In place of y, we will get dy by dx. In place of dy by dx, and put dy by dx equals to p variable. Then what is going to become? Total equation converts in terms of p and x. Then it reduces to a differential equation reduces to a differential equation in terms of P and X or X and P variables. Okay, so solve it, then we get what we get. P in terms of X variables. In terms of X variables. So what we have to do is substitute this P in the given equation number 1. Then substitute this P in equation 1. Then we get general solution of given differential equation 1. Then we get general solution of given differential equation 1. Okay, so this is a process of what? Solvable for y. So now I'm taking in the same manner, what is the solvable for x? So I just mentioned as solvable for y only, or here only in the procedure itself, I'm saying that solvable for y or and solvable for x. That means both the methods we are discussing at a time. Both the methods we are discussing at a time. So first point is solvable for y, as we discussed here clearly, and the next point is solvable for x. What is the solvable for x? In case of solvable for x, what we will do? So what is it? Here I'm taking it as a second point. If given differential equation cannot be converted in terms of a linear or product of linear factors in terms of P, then either it may be converted to solvable for y or solvable for x. So when it will be solvable for y, if the degree of y is 1 in given differential equation, then we have to write, we have to apply solvable for y. Okay, so same manner, if the degree of this thing is which one? If degree of the equation is degree of x is 1 in given differential equation, then we have to apply solvable for x method. Okay, so in case of solvable for x, what we have to do, like what we did in our previous step, same thing we have to write. Okay, so let me take copy everything. So taking as it is here also, going to get the same thing, but here what we have to take? What we are going to get? What is our procedure? So same manner, how we have to write equation number 1? We have to write equation number 1 as x is in terms of y, x is in terms of y comma p. Write equation number 1 as x is in terms of y comma p variables, and given differential equation, differentiate the given differential equation on both sides with respect to which variable? Y variable. Okay, we have to differentiate with respect to y variable. If we differentiate on both sides with respect to y variable, what we will get? Dx by dy we will get. So put dx by dy is equals to What is dy by dx? Generally p. Then what is dx by dy? Is 1 by p. This is important. Okay, then it reduces to, which one reduces to? Equation 1. Substitute all these things in equation number 1. Then it reduces to, how it reduces to? It reduces to a differential equation in terms of y and p variables. Then solve it, then we get p in terms of y variable. Then substitute this p in equation number 1, then we get a general solution of a given differential equation 1. This is the general process. This is the process. Okay, so we'll do problems how we have to do it. Okay, so I'm going to give the first problem on this model. So first problem, simply they'll mention solve xp square minus 2yp plus x is equals to 0. So if we observe this differential equation, how it looks like? It is a polynomial in terms of p variables, but check it whether can we write it in the form of linear factors of product of linear factors in terms of p. Is there any possibilities? So let me write, given differential equation is xp square minus 2yp plus x equals to 0. Okay, take this is equation number 1, and first of all check whether it is a first order only. Yes, p is nothing but divided by x, it's a first order. What is the degree of this differential equation? What is the highest power of p? Is 2. So it is a second degree first order, but not first degree. That means first order second degree differential equation. So for this we are unable to apply exact, non-exact, linear, Bernoulli's, all these methods. So only one method we can solve it is, it may be solvable for p or y or x, that we have to identify. So if we observe equation 1 cannot be right in the form of factors. Why? If we observe here x is, p square coefficient is x and the constant term is x. The product of two values is x square and their sum must be minus 2y. Their sum must be minus 2y. Is there any possibility like this? No, it is not possible, surely. So because of that reason, we are unable to convert it into product of linear factors. So therefore, clearly, equation 1 cannot be written as product of linear factors. Product of linear factors. So whenever it is unable to write the product of linear factors, what we have to do? We have to convert it into either solvable. We have to apply the process of solvable for y or solvable for x. Okay. So which one we can apply? What is the process we discussed? What is the condition? If the degree of y is 1 in the given differential equation, then we have to apply solvable for y. That this is the process. If the degree of x is 1, then we have to apply solvable for x process. But if we observe x power is 1 is there, y power is also 1 is there. But I mentioned one more point here. If then write equation 1 as y is equals to only function in terms of x and p variables. Or same manner, if x power is 1 is there, then x should be written in terms of y and p only. So that means either y or x should be linear powers, but it should contains only in one term. But here x is there in two different terms. X is there in two different terms and x power is 1 only. So in more than one term contains, so we cannot apply x. So and what about y variable? Only linear powers of y is there, that too it is only available in one term. So we can convert it into, we can apply solvable for y. So clearly we have clearly we have y variable only in one term. This everything is not required to write in your examination. This is just for your understanding purpose. I am writing it here. One term, and it is it is linear. Linear is nothing but power of y is 1. Power of y is 1. This is the thing. Power of y is 1. Then only we have to apply this process. So what is this process we have to do? So differentiate equation 1. Okay, first of all, I am going to write equation 1 like this. Equation 1 implies, how we can write equation 1 as okay, I'm taking a minus 2py to right hand side, all the remaining terms to left hand side only. Xp square plus x equals to 2yp. With this, what we can conclude? 2y is equals to, take p to another side, what it will become? X into p plus x by p. It is better to write like this always. Y coefficient may be constant or maybe 1. So please make sure that we have to convert like this. After we convert like this, then only apply differentiation on both sides with respect to which variable? X variable. Differentiate with respect to x variable. X variable. If we differentiate on both sides with respect to x variable, then what is going to become? Left hand side will become 2 into dy by dx. But right hand side, what about the first term? Xp. So x is in terms of x, p is also in terms of x. What is p? P is nothing but dy by dx. Dy by dx may be in terms of x and y variables. So that we have to apply here differentiation of uv formula. If we apply the differentiation of uv formula, what we'll get? U into v dash. What is the v? P, dp by dx, plus u dash or v into u dash. What is u dash? Differentiation of x with respect to x is 1, plus now x by p. Use x is in terms of x, p is also in terms of x. Use u by v formula. U by v differentiation is vu dash, so p into u dash. X differentiation with respect to x is 1 minus x into v dash. V dash is u into v dash is x into dp by dx by v square. What is the v value? P. So we'll get p square. So do the simplification, but we know that dy by dx equals to p. Put dy by dx equals to p. By substituting this, what is going to become? Left hand side becomes simply 2 dp is equals to x into dp by dx plus p plus p by p square is nothing but 1 by p minus x by p square into dp by dx. dp by dx. Okay, so these are the things. Now, going to do, please check. I'm going to take a dp by dx common from these two terms. What is going to become? What is going to become? If I'm taking dp by dx common, what we are going to become? X minus x by p square. But I'm taking x also common. So what we can get? 1 minus 1 by p square plus, from the remaining two terms, I can write p plus 1 by p. But so we are having left hand side is 2p as it is, and I'm bringing everything to one side only. So this 2p also I'll take it to right hand side. Then what is going to become? X into, okay, that right hand I am writing as a left hand part. Okay, so x into dp by dx What is the coefficient of dp by dx? 1 minus 1 by p square. So taking LCM here, then what we'll get? Denominator will be p square, numerator will be p square minus 1 plus p plus 1 by p minus 2p is equals to 0. Then on simplification, what we'll get here? I am taking the doing the simplification of second part. So p plus 1 by p, nothing but 1 by p minus p is equals to 0. So I am writing the first term will be as it is, dp by dx, coefficient will be x into p square minus 1 by p square. But here, if we take LCM in the second term, what is going to become? P square, numerator will be 1 minus p into p is p square is equals to 0. So, sorry, denominator will be only p is LCM, then numerator becomes 1 minus p square. Okay, so same manner, if when I can take 1 minus p square by p common, if I can write it is as p square minus 1 by p into x by p. Okay, so from both the terms, I'm going to take this one common. But here it is positive and here it is negative. So because of that reason, what I am going to do is I'll take a p square minus 1 by p only common. If we take a p square minus 1 by p common, then what is going to become? The first term becomes same x by p into dp by dx. But when it comes to the second term, we are taking p square minus 1 by p, but here 1 minus p square by p. So if I am taking minus common, we'll get here negative sign minus, what is the rest of the part? Will be 1 is equals to 0. Now, from these two factors, what we have to understand is, now check the first factor. Check the first factor which is in the red color. So this first factor is not in the terms of p and x variables. So we cannot find a solution for this. So because of that reason, if we check, we cannot consider the first one. So take the second factor. If we take the second factor, which is in the blue colors, which I have written, so this is a differential equation in terms of x and p variables. And if forget about p is dy by dx, so treat this is a first order, first degree ordinary differential equation in terms of x and p variables, then we can find the solution for this easily. Then from that we can get p is in terms of x variables. So because of that reason, which do not contain x variables, which one? This cannot take, because which do not contain x variable. Because of that reason, we cannot solve this one. So which one we have to solve? This one we have to solve. By solving, by now I'm going to take that implies x by p into dp by dx minus 1 equals to 0. That implies taking minus 1 to right hand side, it will become as x by p into dp by dx equals to 1. Now using trying to separate the variables so that dp by p will be left hand side, all the x variables taken to right hand side, x by dx is in product to the left hand side and taken to right hand side will become as dx by x. So by observing this, what we can say that variables are separated. Okay, so variables are separated. By using the variable separable method, we are going to apply integration on both sides. Integration on both sides. When we apply integration on both sides, what we are going to get? We are going to get integration of 1 by p into dp is equals to integration of 1 by x into dx. So what is integration of 1 by p into dp is nothing but log p. That implies log p is equals to integration of 1 by x into x is log x plus we have to take integrating constant. We can take it as plus c or log c. Because why I'm taking log c? Because all the terms got log form. So taking it as log c. That implies right hand side is look like a log a plus log b form. Log a plus log b can be written as log of ab. So log of cx or xc we can write. That implies log a equals log b, then a is equals to p. Then we can say p is equals to c into x. So what we discussed in our procedure, after getting p is in terms of, okay, let's check. Okay, check it. What we got. Then write equation 1 as y is in terms of x and p variables that we have written, and differentiated equation 1 with respect to x variable. Yes, we did it. After doing differentiation, put dy by dx equals to p. Then it reduces to a differential equation in terms of x and p variables. Yes, it reduced. Solve it. Then we get p in terms of x variables. We got it. Then substitute this p in equation number 1. Then we get general solution of the given differential equation. That means what we got just now, p is equals to cx. That p equals to cx, we have to substitute in equation number 1. Then we get the general solution. Okay. So what is the statement we have to write? Substitute in equation number 1. That implies, what is our differential equation? X into p square. Let me write the differential equation minus 2y into p plus x equals to 0. Now in place of p, what we are substituting? Cx. So x into cx whole square minus 2y into cx plus x equals to 0. This is a thing. So simplify this. C square x cube minus 2cxy plus x equals to 0 is general solution of given differential equation. Given differential equation of first order, but not first degree. This is the process of solvable for y. So same process solvable for x also. So same manner, I'm giving few problems for solvable for y. Okay, so solve y equals to 2p into x or x into p, anything minus p square. So if you observe, this differential equation is cannot be written in terms of x and y. Okay, linear factors in terms of p, product of linear factors in terms of p, or even it can be converted. But if you observe, y power is only 1 and x power is also 1, and y is only having one term, x is also having only one term. So because of that reason, we can solve this differential equation number 2 using solvable for y method or solvable for x method. Better to go for solvable for y. Why? The reason is y coefficient is only 1, and all the remaining 2 terms where we are not having y variable or not having any fractions. If we want to convert it into solvable for x, then what is the process we have to do here? That implies 2px is equals to y plus p square. Then divide with the p. Then what we'll get to x is equals to y by p plus p square by p is p. So like this. So what are the difficulties? We did not get any difficulty in the previous problem, but still it can be solved from here onwards, solvable for x. So okay, this is another option. But giving the next third problem, solve y equals to 2x into p plus x square into p power 4. So p power 4 and p is there. So is it possible to write a linear okay, product of linear factors in terms of p. Yes, we may try it, but here the highest power of p is 4 is there. That means we have to write it in the form of product of factors in terms of linear factors of p, like 4 products. So p power 4 is there, so 4 products we have to write. So it will be a little bit difficult. So because of that reason, uh, check whether it can be solvable for y or x. Check it out. So if I am checking this one, then what is the y power? Is only one. Only one term contains y variable. So we can solve this one using solvable for y. Solvable for y. For example, check in the same manner, is it can be used for solvable for x also? What is how many number of terms contains x variable? 2 terms. So no need to worry about it. So we cannot go for solvable for x for this problem. Or we can say that x power is 1 is available, but here x power 2 is available. Even it is x power 1 only. For example, in place of x square also we are having x power 1, but there are 2 terms which contains x variable. So because of that, but y it contains only in one term, but x contains in 2 terms. So because of that reason, we have to avoid, we are not able to apply solvable for x. This is the process. Okay, so now the next concept is Clarets Form. So I just mentioned how to go for solvable for y and solvable for x. Same manner here. One more method is there. Clarets Form. What is this Clarets Form? Clarets Form is simply solvable for y only. Solvable for y only. But the differential equation can be written in terms of a particular manner, then we can find the solution directly. The differential equation of the form y equals to p into x plus phi of p is said to be, this form is said to be in Clarets form. In Clarets form. What, Mr. Rajkumar? I'll mark you absent. 350. Please make sure that the differential equation of the form y equals to px plus phi of p is said to be in Clarets form. Then its solution is, if the given differential equation is in this form, then we can write the solution like this simply. Y is equals to, in place of p, we need to take a arbitrary constant c. So what we'll get? Cx plus phi of c. This is a solution, direct step. This is a 2 marks bit. This is 2 marks bit. Surely they will ask a question on this. For example, here, if you observe, okay, it should be y equals to px plus phi of p only. It should not be in any manner. So if you observe the second equation, how it looks like? Y is equals to px plus phi of p, but here it is 2 is there. So we cannot solve this differential equation number 2, that is the second problem, using Clarets form. So I'm giving you some examples for Clarets form. So one example is, solve y is equals to x minus 3 into p minus p square. Now we have to convert this differential equation into Clarets form. That is very important. Okay, so solution is y is equals to, I'm multiplying with I'm separating it. So we'll get x into p minus 3p minus p square. Now observe this clearly how it looks like. Y is equals to p into x plus, how we can write it? Minus 3p minus p square. Now what is the brackets? Brackets is like in terms of function in terms of p variables. Now check here our process. Y, yes, y is there. P into x is there. Next term is function only in terms of p variables. Yes, it is there. So now we converted our differential equation to is in Claret's form. Claret's form. By using the Claret's form, what is the solution? Then its solution is its general solution, not solution. Anybody can say? Simply y equals to cx minus 3c minus c square. This is the general solution of this differential equation. Okay, there is the advantage of Claret's form. But if I don't want to do this, then what is the general process you have to do? You can do this differential equation is a linear powers of y, and already y is in terms of x comma p. So y కూడా ఒక్క ఫస్ట్ టర్మ్ లోనే ఉంది, ఒక్క లోనే ఉంది, అది కూడా లీనియర్ కాబట్టి then we can go with solvable for y also. If you go for solvable for y also, you will get the same solution, no problem at all. Okay, so going to check one more problem here. They are giving a problem like this. So second problem is solve y square minus 2pxy plus p square into x square minus 1 is equals to m square. Don't know about m square. Okay, this is the equation, but we need to check what is the power of y is 2. So can we go for solvable for y? No. Is it what is the power of x? Highest power of x is 2, so we cannot go for solvable for x also. So because of that reason, we have to observe carefully. Can we convert it is in the form of Claret's form or not? Solution given this. Given differential equation is this one. Now what I'm going to do is I'm going to simplify this here, right hand side. Okay, sorry, these two terms I'm multiplying with p square, x square minus 1. Then what we're going to get? Y square minus 2pxy plus p square x square minus p square is equals to m square. Now if you observe how we can write this one, y square minus 2 into y into px. But how we can write p square x square as px whole square? Now minus p square taken to right hand side, m square plus p square will get. Now if you observe, it is a square minus 2ab plus b square form. How we can write using our general process? A minus b whole square. So y minus px whole square is equals to m square plus p square. Now from this what we can write? Y minus px equals to, can I take the square left hand side square to right hand side, it will become square root of m square plus p square. Okay, so next I am taking minus px to right hand side, it will become y is equals to px plus root of m square plus p square. Now what you can confirm with this is in Claret's form. Yes or no? Claret's form. So because of it is in Claret's form, what is its general solution? then its general solution is what is its general solution? Anybody can say? In place of P, what we have to do? We have to replace with the arbitrary constant. So y is equals to Cx plus root of m square plus c square. Then its general solution is this one. So hence this is a solution. Okay, you can say as sir, if we apply square root on both sides, then we may get plus or minus. Yes, you can mention plus or minus is also a solution. Okay, so this is end of solvable for P, solvable for X, and solvable for Y. So same manner, find the solution of these equations. That means all these are the examples. I am giving you a clue. That clue is all these examples are related to solvable for, okay, Claret's form. All these are examples of Claret's form, and I given the clue, so you convert all these problems to Claret's form and find its solutions easily. Okay. So next, I'm going to explain a problem on solvable for X. How we have to go with it, that we'll see it here. So here, I'm taking a problem. Better I'm taking solvable for X. So this problem which I am going to give you, okay, let me give solvable for X. Procedure already discussed. Now I am going to give you the problem. One problem I am giving here. Solve y equals to 2px plus y square into p cube. This is a problem. But here, what is a power of y is only 1. But how many terms are there? Only one term. So we can go for solvable for y. Okay, no problem at all. But only because of a reason, I am going to explain at least one problem on solvable for X. So I'm not going to solve this one for Y. Okay, but okay, sorry. We cannot go for solvable for Y because what is the reason? Here it is y power is 1, but when it comes to here also we are having y variable, but it is of order 2. So we cannot go for solvable for y only, and we cannot go for solvable for p also. Why? The product of okay, here p cube is there. Whenever it is p cube, then it is difficult to write as linear factors in terms of p. So I'm not going for solvable for y, solvable for p. Then let me check whether it can be solved by using solvable for x or not. Check. So one term contains x variable, that too it is a linear power. So it is a linear power, so we can solve this differential equation only by using solvable for x. Okay, so writing the given differential equation like this, solution. Writing the given differential equation like this, only 2px I am keeping one side. 2px equals to y. Okay, left hand side y is that I am writing as right hand side, and right hand side in the previous step y square plus y square p cube is there. That should be the left hand side part in this equation, but I am taking to right hand side. It will become minus y square into p cube. Now according to our earlier discussion, we should have only x should be in terms of y and p variable. Because of that reason, I'm going to write this as multiplying with p on both sides. Okay, divide with p on both sides. Then we'll get 2x is equals to y by p minus y square p cube by p is simply p square. This one. Now this differential equation, okay, this differential equation I'm going to we are going to do differentiating on both sides with respect to which variable? Y variable. With respect to y variable. If we do differentiation on both sides with respect to y variable, what we'll get? 2 into dx by dy is equals to, right hand side is in terms of y by p form, differentiation of u by v. So what is the differentiation of u by v? V into u dash is 1 minus u into v dash is dp by dy by v square, nothing but v square, minus, this is again in terms of differentiation of uv form. So y square is u, p square is v form. So y square into that is u into v dash. V dash is 2p into dp by dy, because doing differentiation with respect to y, dp by dy plus v into u dash. P square is constant, differentiation of y square with respect to y is 2y. So now you have to go for simplification. If I go for simplification, what we have to substitute in place of dy by dx? P. But in place of dx by dy, what we have to substitute? 1 by p. 1 by p. This one we have to substitute. dy by dx is p, then dx by dy is 1 by p. So substituting it, it will become 2 into 1 by p is 2 by p is equals to p by p square, nothing but 1 by p minus y by p square into dp by dy minus or 2y square into p into dp by dy minus 2yp square. But now what I'm going to do is I'll bring all the terms to one side only. That means the left hand side, whatever we're having 2p, also bringing to right hand side will become minus 2 by p. That implies I am writing it as all the terms as left side only. Okay, so 1 by p. Okay, meanwhile I am going to write the terms which are not having a dp by dy one side, and the term, okay, one side means like group of terms wherever dp by dy is available, one group of terms, dp by dy is not available, one group of terms. So it will become 1 by, okay, first I am writing a non-group of terms, 1 by p minus 2 by p square, and this 2 by p bringing to right hand side, it's become as minus 2 by p minus y by p square into dp by dy, sorry, minus 2y square p into dp by dy. Everything taken to right hand side, but I am writing it as left hand side. So no need to worry about it. So now if we observe from these two terms, what we can say? From these two terms, we can say minus 1 by p, minus 1 by p. So minus 1 by p minus 2y into p square. From these two terms, what I'm going to do is I'm taking dp by dy common. Other than dp by dy common, anything else we can take common? Check it out. Here we are having dp by dy coefficient is y by p square. Here it is y square p is there. So we can take y common, nothing else. So if I'm taking y also common, then what we are going to get, the first term, okay, minus also I'm taking common. What is the first term? Okay, third term contains 1 by p square plus minus y we have taken common. So plus yp will be there. Sorry, 2yp will be there. Okay, this is the thing, equals to 0. But taking minus 1 common from all the terms of left hand side and taking to right hand side will become plus terms already. Okay, 1 by p minus 2y into p square, sorry, plus minus 1 common, this is plus 1 by p square plus 2yp into y into p by dy is equals to 0. But from the first two group of terms, can I take p common? Can I take p common from the first two group of terms? But we are not having p in the first term product, but still I'm taking p common from the first term also. It will become p into, p is not there, so we have to divide with p. So it will become p square plus 2yp plus if you observe here, 1 by p square plus 2yp into y into dy by d, sorry, dp by dy equals to 0. But if we observe, it's clear that 1 by p square plus 2yp is common for both. So if I am taking that common, 1 by p square plus 2yp taking common, then we are going to get p plus y into dp by dy equals to 0. This is the thing we are getting. Now, as we discussed in our previous case, I think I did not discussed clearly in the previous case. What is the solvable for y? We discussed one problem in this. This group of terms do not having any differential term. This group of terms having differential term. And this here we are having only one variable. Even we have p and x variables, but until unless we have the differential term, we cannot find the solution for this. Because of that reason, we are not going to solve this one. Okay, and same manner, but when it comes to the second factor, it contains a differential term. This second factor contains differential term, so we can solve it. That I have written here, which do not contain differential term, so we cannot solve this one. It contains differential term, so we can go for solving this this factor. Same manner here, if we observe in this problem, which term contains differential term? Only this term contains differential term. So we can go for finding the solution of this one. But the first factor does not contain differential term. So we are unable to find the solution for this. Because of that reason, what I am saying, this one can't be solved. What is the reason? Due to no differential term, or differential term not available. Can't be solved due to no differential term available. And same manner, it can be solved. It can be solved due to differential term available. Differential term available. Okay, so with this condition, I'm going to okay, I'm marking with red color also. This cannot be solved. This can be solved. So I'm going to take a p plus y into dp by dy. That implies p plus y into dp by dy. What we discussed in procedure, we are going to get a differential equation in terms of p and y variables, solve it for then we get the general solution in terms of p and y variables. But now if we observe, this differential equation is a first order first degree ordinary differential equation in terms of p and y. Here we need to find the solution. For finding the solution, I am going to we can convert it into variable separable method like this. So here dy by y plus dp by p, we can write it. How we can write? Multiply with the dy by y into p on both sides. Okay, then we can get like this. So if we observe, first term contains only y variable, second term contains only p variable. So because of that reason, your variables are separated, and using that variable separable method, we can say that apply integration on both sides. When we apply integration on both sides, what we are going to get? Integration of 1 by y into dy plus integration of 1 by p into dp equals to integration of 0. So integration of 1 by y into dy is log y plus integration of 1 by p into log 1 by p into dp is log p is equals to integration of 0 is 0 plus log c. I am taking log c because of we got both terms integration is log only. So using the left hand side, log a plus log b is log ab. So log yp is equals to log c. Using the property of logarithms, a is equals to b. Then we'll get yp is equals to c. But with this equation, what we need to find? We need to find y is in terms of p is in terms of y variables. P is equals to c by y. So where we have to substitute this one in equation number 1. What is equation number 1? This is our equation number 1. So taking y is equals to 2px plus. So substitute in equation 1. That implies, first I am writing the equation number 1. Y is equals to what is it? 2px plus y square into p cube. So in place of in place of p, we have to substitute c by y. So 2x into p value is c by y plus y square into c by y whole cube. Okay, on simplification, what we are going to get? Y is equals to 2cx by y plus c cube by y cube into y square becomes y. So we can take LCM is y common right hand side. Okay, 1 by y we can take common, then bringing to left hand side will become y square is equals to 2cx plus c cube is the general solution of given differential equation. Is given differential equation 1. Which method we discussed here? Solvable for x. So these are end up solvable for p, solvable for y, solvable for x, and one more concept we discussed, Clarets Form. So these are the problems for your practice on solvable for x. Okay, with this I am closing. I am ending this.